So I'm just going to talk about standard molar Gibbs energy. And then after this slide, I'm going to end the video because I'm liking how these quick lectures go. Okay. And so I'm just going to talk about standard molar Gibbs energy very briefly. So it's just like all of our other chemical quantities, right? So delta G of, let's say, a chemical reaction, right, we know is the sum of the free energy of formation of the products minus the sum of the free energy of formation of reactants. So like that classic Gen Chem stuff. But what I really kind of wanted to get into with this, so we note that also delta G of a reaction, we can write, I'll put the 0 there for standard. We can write delta H minus T delta S, this relationship that we've been talking about. And what we really recognize, we should really recognize that this is dW. This is work, okay? So let's look at something like carbon dioxide, negative 394.4, okay? So what this is saying, when we take carbon and oxygen and form carbon dioxide, so that's what this molar Gibbs free energy means, formation of the elements from their standard states, okay? It's spontaneous, right? Negative 394.4, hugely spontaneous, okay? That doesn't mean that it's going to happen quickly. Thou shalt not mix kinetics with thermodynamics. They often maybe correlate, but they don't necessarily propagate to the same thing. Like if something has a large delta G, a large negative delta G, it doesn't mean that it's necessarily going to happen quickly. But what it does mean is if you have a bunch of carbon and a bunch of oxygen and a whole lot of time, undoubtedly, the carbon dioxide will form spontaneously. It will happen without you even wanting it to happen. And the bigger picture idea of that is nature is providing the tax refund on the internal energy as it is converted into work, okay? So in other words, nature will force those electrons through the orbitals, in the case of this chemical reaction, spontaneously. Benzene, diamond, not so much. And that makes good sense for diamond, right? You know that you need a lot of pressure and temperature to make that happen. You're not going to form a diamond spontaneously from a lump of coal at 298 K. You need a ton of input. So you have to provide the taxes for that situation. Okay? So I'm going to cut it